All right, 8.3, law of sines. Okay, last time we started learning about trigonometric ratios. Now we're going to start working with our law of sines. So first, example 1, how can you use the sine ratio to relate the lengths and angle measures in triangle ABC? So the first thing I want to do is drop down an altitude. It's going to form a 90-degree angle. I'll call that D. Okay, so now I have a 90-degree angle. I've got a right triangle. I've got two right triangles. I can use my trigonometric ratios. Right, and they want us to discuss how we can use these sine ratios to relate length and angle measures. Okay, so we're going to first look at sine of B. So sine B. So sine, again, we can do our SOHCAHTOA. So sine of B, we would have opposite over hypotenuse. So if I'm looking at angle B here, opposite over hypotenuse, opposite would be, I'm going to name this H, would be H over my hypotenuse, which would be C. I want to isolate my H, so I'm going to multiply both sides by C. So I'll end up with C sine B equals H. I'm going to do the same thing for angle C. So sine C. So we're using this angle now. We would do opposite over hypotenuse. So my opposite is still H. My hypotenuse this time is B. I want to put this in terms of H. So I'm going to multiply both sides by B. So I end up with B sine C equals H. Okay, so H has to be equal to H, so I know that C sine B is equal to B sine C. Okay, and this would end up simplifying to sine B over B equals sine C over C. Okay, let's look at the triad. For triangle ABC, sine B over B equals sine C over C. So that's what we just determined in our first example. We want to show that sine A over A equals sine B over B equals sine C over C. Okay, so for this one, we're going to construct our altitude off of vertex B. Okay, so my altitude would be roughly right there. This would form a 90-degree angle. I'm going to name that altitude K. Okay, so now I'm going to create my sine for angle A. So sine A. I would do my opposite over hypotenuse. So if this is A, my opposite would be K. And my hypotenuse is C. I want to save this in terms of C, or in terms of K. So I want to multiply both sides by C so that I can get K by itself. So C sine A equals K. I want to do the same thing for sine of C. So sine of C, opposite over hypotenuse, so K over A. Multiply both sides by A so I can get K by itself. End up with A sine C equals K. Well, K is the same as K, so I can set these two equal to each other. So C, this should be a lowercase, C sine A equals A sine C. Once I simplify this, I can end up with sine A over A equals sine C over C. Okay, and we already know that sine B over B equals that. Okay, next we're going to look at law of sines. So our law of sines tells us that for any triangle with side lengths of A, B, C, and opposite angles A, B, C, we can use the law of sines for our lengths of the opposite sides. Okay, so that's what we had just created. Okay, so for triangle XYZ, what is YZ? So we're looking for YZ, this side. Okay, so the first thing I'm going to do is I'm going to look for an angle that has a side opposite it. So this angle has this side opposite. The side that I'm looking for has this angle. So I can set up my law of sines using the information that I have. So I'm first going to set up the angle with the opposite side. So sine of the angle that I have, that 77, with its opposite side, which is 7. And I set that equal to the other angle, so sine of 51 over its opposite side, which I don't know. We're looking for YZ. All right, to simplify this, we cross multiply. So YZ sine 77 equals 7 sine 51. Divide both sides by sine 77. YZ will equal, I go ahead and plug all of this into my calculator. So 7 sine 51, divide that by sine 77. That's going to give me 5.6. Okay, so that tells me that this side measurement is 5.6. Okay, let's do that again on our try-it. We want to find the length of XZ. So XZ, we're looking for this side, which I need this angle measure in order to use the law of sine. They didn't give me that, but I know I can find that angle measure because I have the other two angles. So if I take 180, subtract off the two angles that I do know, that's going to end up leaving me with what is left for that angle. So that angle has to be 52 degrees. Okay, now I can set up my law of sines. So again, I use my opposite angles. So sine 77 over 7 equals sine of 52 over XZ. Cross multiply. Divide by the sine 77 to leave XZ by itself. Once I plug all of that in my calculator, I'm going to get 5.7 for the measure of XC. So example 3, we want to find the measure of angle R and angle S using the information that's given to us in RST. Okay, so the first thing I want to do is I want to identify the information that I have. So I have angle T and I have its opposite side. I don't have angle S, but I have its opposite side. So I'm going to use the law of sines to set this up. I'm going to set up my angle that I know, sine of 74, with it over its opposite side, 12.3. and then I would set it equal to the angle S, sine of S, over its opposite side, which I know, 12.7. I cross multiply. Divide by the 12.3. Okay, once I calculate that, I would get 0.9925 equals sine of S. Okay, I'm going to use my inverse sine, so sine -1. Okay, so I'm going to take the inverse sine of the 0.9925 that I just found. That's going to get me my measure of angle S to be 83 degrees. Okay, so I found the measure of angle S. Now I need to find the measure of angle R. Instead of doing the law of sines again, I know that all of the angles inside of this triangle have to add up to 180 degrees. I have 2 of those angles, so I can take the 180 degrees, subtract off the angles that I know to find what is left for the measure of angle R. So the measure of angle R would have to be 23 degrees. Okay, or try it. We want to find the measure of angle N, so we're looking for this angle right here. We have the 70 degrees and its opposite of 4, so sine of 70, let me move down a little bit, sine of 70 over 4 would equal my sine of N over 2, cross multiply. Divide by 4, and end up with 0.4698 for sine of N. I'm going to take the inverse sine of the 0.4698, which will give me a measurement of 28 degrees. So measure of angle N is 28 degrees. Okay, measure of angle O. Well, I know that all of them have to add up to 180 degrees, minus the angles that I know. And I would get 82 degrees. Okay, looking at example 4, we have a map that the flight crew used between Omaha and Chicago. They ran into a thunderstorm and they had to reroute. How much longer is this route than their direct route to Chicago? Okay, so we need to be able to find 2 measurements. I'm going to name this X and this Y. I know that my missing angle here would have to be 45 degrees. And I can use the law of sines to find those missing measurements. Okay, to set this up, I would have sine 113 over the 471 miles equals my sine, I'll do X first, 22 over X, cross multiply. Divide by sine 113. So X will end up equaling 191.7 That's miles. Now I need to find the measurement for y. Do that below. So again, I can use the same beginning part. So sine of 113 over 471. We're looking for y this time. So that angle would be 45. So sine 45 over y. Cross multiply. Divide. And y will end up equaling 361.8 miles. They wanted us to figure out how much longer the route around the storm is instead of going directly to Chicago. So if we went directly, it would be 471 miles. We want to figure out how much of a detour we had to take. So we're going to add these two together, 191.7 plus 361.8. So we went a total of 553 miles, 0.5. We're going to take how far we traveled and subtract from that how far we would have traveled if we went direct. So we were off course. We went 82.5 miles farther. Okay, or try it. All right, suppose the pilot chose to fly north instead. How much farther is that route than the direct route? So again, we'll use law of sine. They told us one of our side measurements already. So we can set up our law of sine. So sine 148 over 471 equals sine of 22, I'm going to call this side x, over x. Cross multiply. Divide by sine 148. So x would end up equaling 230.04 miles. We want to add our two segments together. So the 230.04 that we just came up with, plus the 260 that they gave us. So we would have to travel a total of 490.04 miles. We want to know how much farther that is from our original route. So we'll take the 490 and subtract off our original amount of 471 that we would have traveled to get from Omaha to Chicago. And that would be 19.04 miles. Okay, so going north would be a shorter route than going south.